everyone, let's look at problem number 5. So Eric's disabled sailboat is floating stationary 3 miles east and 2 miles north of Kingston. A ferry leaves Kingston, heading towards Edmonds at 12 miles per hour. Edmonds is 6 miles due east of Kingston. After 20 minutes, the ferry turns, heading due south. Ballard is 8 miles south and 1 mile west of Edmonds. Impose a coordinate with Ballard as the origin. Alright, so we have Ballard is the origin. So impose a coordinate system says that we draw x and y axes. So we have x axis, and we have y axis going up. That's the y axis right here. Okay? So Ballard is at 0, 0. That's at the origin. Okay. Let's see where everything else is. Let's see. Ballard is 8 miles south and 1 mile west of Edmonds. So that means Edmonds is 8 up and 1 this way. So this is like at 8, 1. So this is like 8 and 1. Do we know where Kingston is? Edmonds is 6 miles due east of Kingston. So that means this is 6 miles between them. So this is at 8 and -5. Okay. Let's see where the sailboat is. So the sailboat is 3 miles east and 2 miles north of Kingston. So we have like 3 this way and 2 this way. Alright, so if I go 2, then I'm going to end up at 10. Alright, and if I go 3, then I end up at -2. Okay, good. So the sailboat is at -2 and 10. Okay, good. So we placed everything on that coordinate system. Alright, let's see. Find the equation for the lines along which the ferry is moving and draw these lines. Okay, so the ferry leaves Kingston and heads towards Edmonds at 12 miles an hour. So it's going this way first. Okay. After 20 minutes, the ferry turns heading south. So we got to figure out how far it went. Right, so we have, first of all, find the equation for the lines. So the first equation that the ferry is like y equals 8. It's moving along that line. But then it turns. Okay, so it's going 20 minutes. So 20 minutes times 1/60. 1 hour is 60 minutes. Then that's 1/3 of an hour. The ferry is going at 12 miles per hour. So distance equals rate times time. Rate is going to be this. We're figuring out the distance. Okay, so the rate of the ferry is 12 miles an hour times 1/3 of an hour. That's 4 miles. Okay, so it goes 4 miles, this, and then it turns. Oops. Okay, so it's going this way. Okay, so this is line y equals 8, and it goes 4 miles. This line equals y equals 8. It goes 4 miles, and it's turning, going south. So this is along x equals -1. Alright, so These are the lines of the ferry. Part B. The sailboat has a radar scope that will detect any objects within 3 miles of the sailboat. Alright, so this sailboat has a radar. Okay, so if I can make like a little circle here, that's the range of the radar. It's like 3 miles. Looking down from above as a picture, the radar region looks like a circular disc. The boundary is the edge of the circle around the disc. The interior is the inside of the disc and the exterior is anything outside. Give a mathematical equation description of the boundary, interior, and exterior of the radar zone. Sketch an accurate picture of the radar zone by determining where the line connecting Kingston and Edmonds would cross the radar zone. I guess let's look at B. So the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k are the center and r is the radius. Okay, so we know it's centered at -2 and 10, so those are the h and the k. So we have x minus -2, so x plus 2 squared, and then y minus 10 squared equals 3 squared. Okay, so this is the equation of the boundary. Now the inside, so the inside would be x plus 2 squared plus y minus 10 squared is less than 9. That's everything on the inside. And outside would be x plus 2 squared plus y minus 10 squared is bigger than 9. Okay, good. Give an accurate picture. Determine where the line connecting Kingston and Edmonds would cross the radar zone. Okay, so we got to figure out where this line is crossing the circle. Okay, so we know that's when y equals 8. So if we plug y equals 8 into here, then we can figure out where the circle is intersecting that line. Okay, so let's plug that in. We have x plus 2 squared plus 8 minus 10 is 2 squared, and that's equal to 9. X plus 2 squared plus 4 equals 9. X plus 2 squared equals 5. We can take the square root of both sides. We get x plus 2 equals plus or minus square root of 5, which means x equals -2 plus or minus square root of 5. Alright, so let's do the math. We have 2 points where it's crossing, and x equals -2 minus square root of 5, which is -4.24, and x equals -2 plus square root of 5, which is 0.23 or 24. Okay, so yeah, you could crossing somewhere here. I think I drew this one a little bit too big. It's crossing in -4.2 and +0.2. So it's like the circle, and it's sort of going this way. This is a really bad circle, sorry. There we go, there we go. Okay, so now the question is, when does the ferry enter the radar zone? Okay, So let's see if we can solve that. So you can see the ferry enters the radar zone at this point and at this point, okay? So we already know the x value at that first point. So that x value at that first point is negative 4.24. And we note that it started, actually, I think I messed this up. This was negative 5 and 8. I switched my x and my y values. Yeah, that's better. Okay. So this is negative 4.24, and it started at x equals negative 5. Okay, so the distance between these, so this is like x1 and x2. So this is like x2 minus x1. Negative 4.24 plus 5 gives me 0.76. So that's the distance that it covered. And I know it's going 12 miles an hour. Okay. So this is how many miles. And it was going at a rate of 12 miles per hour. So the distance, the time, is going to be distance over the rate. So 7.6 divided by 12. 0.76 divided by 12. It's a 0.063 hours. If I multiply that by 60, it's like 3.8 minutes. Alright, so the first time that it enters the radar zone of the boat is 3.8 minutes after it left Kingston. Okay, but there's another point in time which is here. Alright, so let's figure out, that's when x equals negative 1. Okay, so for that we need to go back to the circle. We need to go back to the circle equation, the radar zone, x plus 2 squared, y minus 10 squared equals 9, and plug in x equals negative 1. Okay, and we get 1 squared plus y minus 10 squared equals 9. Y minus 10 squared equals 8. Take the square root of both sides. Y minus 10 equals plus or minus square root of 8. So y equals 10 plus or minus square root of 8. Okay? Let's see what these values are. So 10 plus square root of 8. This is y equals 12.8. And 10 minus square root of 8. This is 7.2. Okay, so let's go back to the picture. So this is when y equals negative 1. We get one y value here and one y value here. We're only interested in the lower one because the ferry is turning south. Okay? Alright. So let's see what the distance covered. So the ferry, in order to get to that place, the ferry covered the 4 miles from the beginning before it turned south, and then it covered this distance between that vertical distance. Okay, so we have the horizontal distance was 4 miles, and the vertical distance is 8 minus 7.2, which is 0.8 miles. So in total, the ferry covered 4.8 miles before it kind of exited the radar zone at 12 miles per hour. Okay, so the time, so distance equals rate times time. Time is going to be distance over rate. 4.8 miles divided by 12 miles an hour. 3.8 divided by 12 gives me 0.4 hours. If I multiply this by 60, that gives me 24 minutes. Alright, so there were 2 times. These times here gives me the answer. When does the ferry enter the radar zone? And the second answer is for part D. When does the ferry exit the radar zone? So this is exit. Okay, so this was for part C and this was for part D. Okay, and where is when x equals -1 and y equals 7.8. 7.2, sorry. That's the where and that's the when. 24 minutes after it starts, after it leaves Kingston. How long does the ferry spend inside the radar zone? Okay, so that's part E. We have the 24 minutes minus 3.8 minutes. Okay, because this is how long since it left Kingston that it exited the radar zone, and this is how long it left from Kingston that it entered the radar zone. So if we subtract, we just get 20.2 minutes. So that's how long it was in the radar zone. All right, that's it for this problem right here.